Is we live? I hope I'm audible. The audio and then we'll start. Okay. So very good afternoon, everyone. Welcome to this another exciting weekend of the YouTube live session. I'm Akash Nigam and I'll be your host for today's session as well. I'm thrilled to have you all here with me as we explore another important topic of the CCNA curriculum. Today's focus will be on Dynamic Trunking Protocol, or as you say, DTP. Whether you are a seasoned network professional looking to brush up on your skills, or say you are very new to networking and eager to learn, this session is designed to provide you with valuable insights and practical knowledge about DTP and its crucial role in network management. For those of you joining us for the first time, a very warm welcome. And to our returning viewers, it's fantastic to have you back. Your dedication to learning and improving your skills is truly inspiring. Before we dive into today's topic, let's take a moment to ensure that we all are set up for a great learning experience. Make sure those of you who are preparing the entire certification track of CCNA with me to have your notepad ready with you so that you can jot down few key points throughout the session. And if you have any question during the session, don't hesitate to drop them in the chat. I'll do my best to address them either during the presentation or a separate dedicated Q&A segment can be launched at the end. If there is any particular moment where you find today's session helpful, do remember to hit the like button and subscribe to this channel. Because guys, your support definitely helps every particular team member of ours to continue to bring you high quality education content. And this ensures that you even won't be missing out any future sessions or the tutorials. Also, feel free to share this particular live session with your friends and colleagues who might utilize or get benefit of this discussion. Now, let me give you a quick overview of what we'll be covering today. We'll start with an introduction to DTP. Okay, last week itself I told you, right, that we will be discussing about dynamic trunking protocol that basically helps automatically to create the trunk links, right? But I even want that although it is providing you an ease of configuration, but along with the ease of access comes some risk factors, right? So we will be taking care of both the scenarios. I'll try to discuss some case studies also, so that you guys can get the exact reflections of the implementations here. Okay, so we'll start from DTP. We'll understand why exactly is it important in the world of networking. Then we'll delve into the mechanics of how DTP works, looking at its various modes and the roles they play in network configuration. We'll also cover some common scenarios where DTP can be particularly useful. And I'll do share some tips and best practices for implementing DTP in your own networks. Talking about DTP, guys, DTP is one of the coolest and the key components of network configurations in terms of configurations as well as management. Okay. And in terms of understanding, it can significantly enhance any particular person's ability to design and maintain efficient, scalable networks. Once we are at the end of this session, each one of you who are attending it throughout the session will definitely have a clear understanding of DTP, how to configure it, how to troubleshoot the common issues that might rise. I'll try to cover each and every particular instance of it. So all the coffees lover outside, do grab your coffee and sit back, as I'll be ready, and this particular informative and engaging session on DTP is going to start soon again. Okay, so once again, thank you so much for joining us today. And this specific commitment of learning and the professional growth is what makes these sessions so rewarding. So without further ado, let's get started with a deep dive into dynamic trunking protocol and its applications in CCNA. Let's begin. We are talking about DTP, Dynamic Trunking Protocol. If I talk about the Dynamic Trunking Protocol, guys, Cisco's proprietary DTP holds its roots within Cisco switches. In the older times, when you used to purchase a particular Cisco device, all its switch ports tended to belong to one of the DTP's previous mode. Although that mode is still available, but now the default mode of the Cisco switches has changed. All the modern devices that you might be taking in hands, the default mode of DTP for those particular Cisco switches over to their switch ports would be dynamic auto. Right? Let's look what else do we have here. Yeah, talking about DTP, Cisco's DTP is basically a proprietary protocol that is used for automatic trunk link creations on catalyst switches. Okay. If you move ahead, we get to know that dynamic auto mode is basically an identification of DTP on catalyst switch ports by default. Yes, DTP is a Cisco's proprietary protocol, as well as it is by default enabled over to its Cisco devices. And do remember, guys, one thing: if there is any entity which is by default enabled in your environment and you are a network admin, very first priority of a network admin is to learn how to disable it out, because the entire network, I'm the owner of my network, and nothing can move even a single data packets, even a single electronic bit of the traffic. It cannot move without the network admin's control. So if there is any particular protocol which is by default enabled, it is your first mandate to understand, learn, and know if it can be disabled, why can it be, how can it be disabled, what are the cases when you'll do it, because if any particular certain things which are introduced to any particular manufacturer device in the plug-in play role, they are not intended to be played in the real environments. So what are the reason for that? That also should be very well understood. I'll suggest never mess with these default enabled protocols. until and unless there is a requirement in the network or you are doing it. So please do it in a testing environment, not in the library. Let's move ahead. Now, here we'll be looking on to different modes of DTP ways. See, in Cisco devices, you have observed the switch ports, correct? What I'm saying is that the Catalyst Cisco switches identify its interfaces as the switch port, and these particular switch ports operate on two variated modes. One category of the modes is called as the administrative mode. And another category is called as the operational mode. I won't term it, or terming it as a category won't be a proper justice to these particular terms. I'll tell you exactly what the case is here. Guys, administrative mode is basically the default mode or the mode in which a network administrator might be configuring the devices interfaces. Whereas operational mode is ultimately the combination of the two end nodes of any particular device's link connectivity. So operational mode can only be answered after the link status identification, whereas the administrative mode can directly be seen over to the interface's switch port. Okay, so whenever you are dealing with DTP, understanding both the modes in DTP might definitely help you to configure switch ports effectively. How does it work? Let's go to that also. So presenting to you the very first mode of DTP, the DTP mode on. First of all, let's have a quick superficial view. How many modes does DTP has? Then we'll get in depth of it, means how to configure, what exactly it does, how exactly the packet flows. Everything we'll see in depth there. First of all, let's just get aware of the names. The very first one is DTP mode on. Second one after is DTP mode auto. Although DTP only holds two specific modes, auto and desirable, but with respect to DTP or with reference to DTP, other particular modes also hold the DTP values. As you can see, technically in the document basis also, auto and desirable are the only two possible modes of DTP protocol that are introduced into Cisco devices. Other than that, we have two new modes that I'm saying are not the original DTP's mode, right? But yes, they are also considered within DTP. The DTP mode on and the DTP mode off. I told you, if there is a protocol that is by default enabled, being a network admin, it is your first mandate to learn how to disable it out. Or if it is disabled, how you'll enable it for your use case. So by switching your DTP mode on and off, that can be done. We'll see how it is done. Before that, I would like to focus on the second part. Why exactly do we need DTP? Imagine a network, an entire layer 2 switch topology. Let's say having 1,000 of devices, 1,000 Cisco devices, 1,000 Cisco switches. Imagine these 1,000 Cisco switches all are connected in a mesh topology. Although that is not technically a possible way of connections, although it is possible, but that won't be a meaningful way of connection. So let's say, imagine just the 1,000 devices are connected in somehow 2-tier or 3-tier manner. Okay. Now, every particular connectivity of the switch must be having multiple VLANs. And if those multiple VLANs traffic needs to propagate between the switches, definitely there is a need of the trunk. Now, I know that as Akash has educated us, in order to create a trunk link, first of all, I'll have to get into the interface. We have seen, right? Trunk link creation is basically a per interface basis creation. So on per interface basis, you'll have to reach on to the interface. After reaching on to that particular interface, you'll have to call out its encapsulation mode so that the untagged frames can be tagged with the VLAN identifications, whether it could use ISL or 802.1q. After that, then is only the possibility where you'll define the trunk link. But the case is, for how long can I do it? 1,000 devices is a huge task, right? So in such cases, these proprietary protocols or these particular services of Cisco's proprietary protocols, they do come handy. Once you use DTP configurations, they are definitely going to help you for the efficient and adaptive network configurations. What happens here? DTP will 110% let you achieve the simplified configuration. Exactly. I don't have to manually define the trunk link configurations here and there, because my time has been reduced, right? And even being a human, typing errors are the most common errors that no one can remove, right? So with this automatic creation or the dynamic creation of DTP, definitely my errors have been also reduced. So that's a win-win situation. Other than simplified configurations, the second thing that you'll achieve is dynamic VLAN environments. Guys, DTP, it adapts to all the changes in the VLANs. Okay, so once your VLAN assignment changes for any particular network with frequent modifications, DTP can adapt it easily. Even it helps for the scalability. Yeah, scalability is a case that has to be taken care in the terms of networks planning, network designing, and existing within the network in terms of any role. Scalability is the key. If you have cracked the implementation or designing on the basis of scalability solutions, and your design or your solution can scale without any particular issues, trust me, you have nailed it, guys. DTP also scales very well for large networks. Thus, your manual trunk configuration management has also been eased out. That is the most easiest thing, because manual intervention means manual power, time investment. Although dynamic implementations also take time, but they are much faster than the manual one because they are preloaded or pre-configured. So yeah. Now, just think, how does DTP exactly works? Ever thought about it? कि DTP काम करता कैसे होगा? कभी सोचा? हमने हमेशा ये सुना है कि सिस्को स्विचेस आपस में DTP फ्रेम्स एक्सचेंज करते हैं, करेक्ट? और DTP के फ्रेम्स को एक्सचेंज करके वो ट्रंक लिंक्स बना लेते हैं, नेगोशिएट करके. So what exactly happens there? Is there some kind of communication that happens between the DTP devices? What do you guys think? I'll tell you. See, let's discuss about the frame exchange scenario of DTP, because that will be something which the CCNA candidates might definitely love to know. Cisco switches में हमने ये सुना है कि DTP के फ्रेम्स आपस में एक्सचेंज होते हैं, DTP एक्सचेंज होता है और ट्रंक लिंक ऑटोमेटिकली बन जाती है विद सम सेट ऑफ इंटरफेसेस मोड्स, करेक्ट? असल में DTP एक्सचेंज करता है DTP फ्रेम्स. आपने CDP फ्रेम सुना होगा, DTP फ्रेम सुना होगा, करेक्ट? BTP अपना एडवर्टाइजमेंट भेजता है. तो DTP फ्रेम स्ट्रक्चर सबसे पहले देखना जरूरी है. ओके, DTP फ्रेम स्ट्रक्चर बेसिकली एक एडवांस्ड लेवल टॉपिक है that is not within your CCNA certification tracks, but you guys should be aware of it, of what exactly is this particular frame structure. आगे आने वाली पढ़ाइयों में it would be easy अगर आप शुरुआत से ही फ्रेम हेडर्स की स्टडी करते चलते हो. ओके, एक DTP फ्रेम स्ट्रक्चर की बात करें तो सबसे पहले आएगी इसमें आपकी टाइप फील्ड. गाइस, फ्रेम हेडर्स में या पर्टिकुलर किसी भी पर्टिकुलर स्पेसिफिक ट्रैफिक हेडर में टाइप फील्ड आइडेंटिफाई करती है उस पर्टिकुलर एंटिटी को. हम यहाँ पर DTP फ्रेम की बात कर रहे हैं। DTP फ्रेम को आइडेंटिफाई किया जाता है विद द टाइप कोड 0x2004। ये बताता है कि आपका जो फ्रेम है दैट इज अ DTP फ्रेम। टाइप फील्ड के बाद आता है आपका नेक्स्ट फील्ड विच इज कॉल्ड एज द वर्जन फील्ड। DTP प्रेजेंटली जिस वर्जन पर रन हो रहा है दैट पर्टिकुलर वर्जन इज वर्जन 1 ओनली। सो वर्जन पे आपकी वैल्यू जो सेट होगी दैट विल बी सेट एज 0x01। फिर आती है आपकी टाइप लेंथ वैल्यू। टाइप लेंथ वैल्यू और एज आई कॉल TLV, तो डिफरेंट वेरिएटेड TLVs। ये वो जगह होती है जहां पर आपके DTP की इंफॉर्मेशन रहती हैं, आप ये समझ सकते हो। ओके, so how many TLVs do we have? We have multiple different TLVs. One is your domain TLV. Guys, again repeating, CCNA candidates preparing for exams, preparing for certifications or interviews, you guys can ignore this particular frame structure discussion as of now. But yes, the more you learn, the more you grow. That is the fundamental that I follow. That's why I'm explaining this part. So yeah, domain TLV is one thing which basically identifies the VLAN management domain to which the switch will belong, right? So it will identify the VLAN management. ये बताता है कि आपका VLAN मैनेजमेंट डोमेन कौन सा है जिस पे स्विच बिलोंग कर रहा है, वो इन्फॉर्मेशन आपको यहाँ पर दिखाई दी जाएगी। डोमेन TLV के बाद आता है स्टेटस TLV। देखो, स्टेटस TLV ये बताएगा कि आपका स्विच का ऑपरेशनल स्टेटस क्या है, स्विच में DTP का ऑपरेशनल स्टेटस क्या है। ऑपरेशनल स्टेटस की बात करें तो आपके पास DTP के ऑपरेशनल स्टेटस में डायनेमिक ऑटो, डायनेमिक डिजायरेबल, एक्सेस एंड ट्रंक, ये 4 स्टेट्स हैं। After status TLV, the next TLV that comes is the type TLV. टाइप TLV ये बताएगा कि आपके DTP के थ्रू जो ट्रंक लिंक क्रिएट हो रही है, व्हाट इनकैप्सुलेशन मैकेनिज्म विल इट यूज। आपने ट्रंक इनकैप्सुलेशन मैकेनिज्म ट्रंक टॉपिक्स के दौरान जो पढ़ा है, वी हैव सीन 2 different types of trunk links. Basically 2 different types of protocol that trunk link utilizes for the encapsulation or the frame tagging. Trunk link 802.1q जो कि एक ओपन स्टैंडर्ड वेरिएशन है, इसको यूज करता है VLANs को टैग करने के लिए अपने ट्रंक लिंक पे, और दूसरा यूज करता है Cisco का proprietary ISL depending upon some certain conditions. Most of the time 802.1q is the one that is preferred. Being open standard and having the support of native VLAN and even the least amount of weightage added with the help of the tag addition, that is of 4 bytes. Type TLV के बाद guys, the final TLV is the neighbor TLV, and this comprises the entire DTP frame of yours. So we do have three values here: type, version and TLV. That is the entire formation of the DTP frame. Type and version you already know. The only key information is basically in the type length value, the TLV field. Domain TLV contains the VLAN management information. Status TLV contains the information of the switch's operational state. That could be either of these particular 4: auto, desirable, or static access or static trunk. Then type TLV identifies the trunk encapsulation protocol. Then comes finally the neighbor TLV. This particular TLV informs information about the neighboring switch's DTP status and capability. Okay, one important thing before proceeding ahead. Although the exact format of DTP frame has not been typically covered within the CCNA exam, but as I've told you previously also, if you understand the key concepts, right, like the concept of TLV, अब आपको पता है कि टाइप लेंथ वैल्यू बेसिकली एक पर्टिकुलर फ्रेम या किसी भी पर्टिकुलर एंटिटी के हेडर में उनको खास इंफॉर्मेशन वैल्यूज प्रोवाइड करने के लिए होती है। और आपको ये पता है कि अब वो किस तरीके से कन्वे की जाएंगे और कैसे वो हेल्पफुल होती हैं। तो जो मेन की टेक अवे कह सकते हो आप डीटीपी फ्रेम्स के डिस्कशन के दौरान, वो असल में होता है कि इन्होंने नेगोशिएट किया है ट्रंक के लिए। ठीक है, ट्रंक मोड्स के लिए नेगोशिएट करते हैं सिस्को स्विचेस के बीच में। तो विद इन अ नटशेल डीटीपी फ्रेम कैसे काम करता है वो समझते हैं। ओके, ठीक guys, you'll get the similar process here. 4-step process is there. So once your frame exchange starts, right, यहाँ पर आपकी 4 स्टेप की प्रोसेस स्टार्ट हो जाती है जो कि डीटीपी को एग्जीक्यूट करती है। सबसे पहला स्टेप होता है आपका इनिशिएशन। इनिशिएशन इज अ प्रोसेस गाइस जब आपका स्विच डायनेमिक ऑटो या डायनेमिक डिजायरेबल मोड पर होने के बाद एक डीटीपी फ्रेम भेजे अपने नेबर को। इनिशिएशन इज द डीटीपी पोर्ट द डीटीपी ऑटो और डिजायरेबल पोर्ट। बट मैं एक कुछ की चीजें हैं गाइस जो मैं एंड में समझाऊंगा आपको। लेट्स फर्स्ट ऑफ ऑल डिस्कस द layman bookish and what exactly Cisco wants to do. Then I'll tell you the key tricks of it. Okay, so see, initiation process is basically the process where your switch, if holding the dynamic auto or dynamic desirable state, sends a DTP frame to neighbor. मैं हूं switch 1. Let's draw it the upper way. So I have switch 1, which is connected via a link to switch 2. This is fast Ethernet 0x1 and this is fast Ethernet 0x8. अभी switch 1 का इंटरफेस फास्ट है 0x1 अगर डायनेमिक ऑटो या डिजायरेबल पर है, लेट्स से डायनेमिक डिजायरेबल पर है, तो it can send and receive the negotiation. That is the power of dynamic desirable port, how it has been manufactured. So इस पर्टिकुलर स्टेट को हम इनिशिएशन स्टेट कहेंगे अगर स्विच 1 एक डीटीपी फ्रेम फॉरवर्ड करता है नेबर को। सेकेंड स्टेट गाइस इज कॉल्ड एज द नेगोशिएशन स्टेट। आपका स्विच रिस्पॉन्स करेगा अपने खुद के डीटीपी फ्रेम के साथ, सो दैट इट कैन रिप्लाई बैक फॉर द इनिशिएशन डीटीपी फ्रेम दैट हैज बीन इनिशिएटेड। तो जैसे ही स्विच 2 ने रिवर्ट किया with the negotiation message containing its own information of the device, they have attained the negotiation state. Because in general यही वो समय है या यही वो वक्त है जब दो क्रॉस डिमांडिंग पोर्ट वेरिएशंस आपस में नेगोशिएट कर सकते हैं। थर्ड स्टेप, if negotiation has started, either there would be an agreement if agreement has been done, this means आपके switches ने negotiate भी कर लिया है and at last agree करने के बाद trunk mode को भी उन्होंने अपने DTP messages के accordingly ही change किया है। Agreement stage proves DTP frames accepted and the encapsulation is as per devices DTP frame. इतना तो हमने देख लिया, बट देयर इज द फाइनल स्टेट. अगर अग्रीमेंट फिनिश होता है तब जा करके आपको कहीं दो डिवाइसेस के बीच में आपको फोर्थ स्टेप विच इज द ट्रंक एस्टैब्लिशमेंट दिखेगा. When both of the switches are agree for the trunking mode and even the encapsulation, तब आपका trunk mode enable हो जाता है. And that is how exactly DTP frame exchange works within the four-step procedure. Now, quickly moving without much ado to the next. Yeah, negotiation modes. नेगोशिएशन मोड की बात करें तो स्विचेस नेगोशिएट करते हैं ट्रंक फॉर्मेशन के लिए अपने स्पेसिफिक मोड के अकॉर्डिंगली. What are the negotiation modes? That is very soon we are going to discuss variety. Encapsulation selection, that is also something which I have told you. And trunk establishment, although it is a dumb option, but yeah, we already know that it is used for trunk establishment. We will here see in the fourth module exactly the proper in-depth learning of DTP. The very first mode here you're looking at is dynamic auto. This is the DTP's dynamic auto. Protocol DTP dynamic auto mode. Guys, dynamic auto mode पर रहने वाला switch हमेशा passively wait कर सकता है trunk बन by expecting कि उसका neighbor एक request initiate करेगा. That means although dynamic auto port wants to become a trunk, but it cannot become trunk at its own. He needs someone to negotiate or initiate a communication with them. That should be the DTP frame communication. So auto port, if not resolved, will definitely sit back as an access port. After auto comes the dynamic desirable. He is the master. Any particular switch in this mode, guys, it will actively attempt to negotiate a trunk link with its neighbor because they are made to do so. Dynamic port variations and the processes are ultimately made exactly by replicating this manual procedure. But with the help of protocols or algorithms, the manual intervention has been lessened up. Now, so always remember, desirable port always wants to become trunk. And it can, yes, it can even negotiate, accept the negotiation rather than sending only. अच्छा, स्विच पोर्ट कॉन्फ़िगरेशंस की बात करें तो स्विच पोर्ट की कॉन्फ़िगरेशंस बेसिकली आप डीटीपी की हेल्प से दो कारणों में डिसेबल करोगे. अगर आपके स्विच एनवायरनमेंट में डीटीपी रन कर रहा है and you are a very security specific person for the security solutions, do disable DTP without asking anyone again. If you want in-depth control of your network to be in someone else's hand, do enable DTP. Guys, the case is DTP का ऑटो मोड आपके हर सिस्को स्विच पोर्ट पर आपको दिखाई देगा. अगर से इंटेंशनली मैं एक स्विच ले आऊं और कनेक्ट कर दूं and this particular port of my switch is, let's say, dynamic desirable. Desirable ports will always initiate the negotiation message. जिस कारण से वो ट्रंक बनाने के लिए सामने वाले को initiate करेंगे. And this particular port auto was looking for some similar such communication. He was expecting something. And once the expectations are met, the negotiations have been heard, they'll form the link which is expected to be trunk. And that particular trunk will be the operational mode of the switch port. By default, we'll always discuss, let's say, even if it is in case of interview and someone asks you administrative mode, please tell me. So yes, you guys are on the same page. He is basically asking your specific letter. Okay, moving ahead. So other than security control, you do get to troubleshoot as well as the compatibility thing. Troubleshooting, I'll show you quickly. There, these particular things will be covered. How to configure. These are the commands basically for the interface and global configuration mode. I'll open a packet tracer here. Okay. जैसे कि मैंने आपको कहा Cisco devices में by default DTP enable होता है. हम देख लेते हैं क्या सच में DTP enable है भी या नहीं. Let's take out another outer ones. We don't need the host, guys. Let's directly connect a switch. This intense configuration we'll see in the case study itself. So I only work over DTP. Okay, so I'll just use two switches to form the DTP connections. Initially, if you want to identify your switch port informations, the command that you'll execute over to your CLI would be show this is the initial configuration of your device. Yeah, so switch has not been touched yet. It's completely free. How I've checked it, I've checked its version number, I've checked its VLAN configuration, nothing is there. Because I've recently picked it out from my inventory. Okay. Now guys, if I check specifically for fast Ethernet 0x1, show interface fast Ethernet 0x1 switch port. This is the command. And if I hit enter, it will tell me the switch port information of Manchester device. See, fast Ethernet 0x1, it has switch port enabled. Administratively mode is dynamic auto. Operational mode is static access. You can see administrative mode and operational mode. These are the two different mode variations. Even the trunking encapsulation, बताया था कि they used to identify कि बेटा कौन सा trunking encapsulation protocol use करना है traffic के लिए. Native VLAN is also there. So all the names that I'm taking, these are the information that you can again refer by referring some older books, and you'll get these particular key references for you. So let's quickly start the basic DTP configurations. I'll reach on to my device's fast Ethernet 0x1. Now see, if I try to assign an IP address here, IP address, it is not taking the command. Why? Because it's not possible to create and particular interface holding an IP in your switch. I'm talking about the physical interface, guys. The physical interfaces of your switches, they are only available there for the data traffic transmission. DTP is a switch generated protocol, which is I can consider as a management protocol. So the management traffic cannot be easily made accessible to anyone. And that is the reason why your interfaces in the switches, they are never assigned an IP address. If you want to assign an IP address over to the switched environments, that can be done by assigning an IP to your VLAN of that network. And that is the most easiest way. what I'll do is please VLAN 1, and this is how you'll be assigning the IPs. This case of virtual interface I have introduced initially because it has to be understood properly. And yes, we will be utilizing some case studies where switch virtual interface is already present. One should be aware what exactly this is. A switch's virtual interface exactly behaves like the physical interface of your router, but for your switch only. Now, let's get back to the. So I'll reach on to my interface fast Ethernet 0x1. I'll ask it to, before changing its interface variations, let's just look directly to its administrative and operation mode. To show interface one, I need to show you the switch port information. Interface fast Ethernet 0x1 switch port information. Look, by default the administrative mode is dynamic auto and the operational mode is static access, because auto has not heard any response from nearby devices. As soon as I introduce a new switch to this domain, now see what will happen. What I have done is this particular end of switch 0 is behaving in its default port state. So in default port state, let's say rather than auto, I have manually configured and changed its port mode to desirable. What will be the operational state of the links? That is the question. Always remember, the DTP is auto mode. It can only accept negotiation. It never initiates. In terms of negotiation, it only accepts. In terms of DTP's desirable mode, it can accept and send both. After that, the other two modes. One is a DTP mode on. As DTP mode on is basically pointing towards your trunk interface, switch port mode trunk command exactly. So once you enable trunk link, it without identifying whether the other end needs a DTP message or not, it will start initiating the DTP messages. That is the behavior of a trunk link. After that, the DTP is off mode. This is something that you need to focus upon. Once your dynamic trunking protocol is by default enabled, it cannot be disabled. Practically, I must say it can be, but verbally speaking, it is not disabled. DTP is an automatic working protocol. That's why it is called as dynamic. Any particular dynamic configuration can be directly bypassed by implementing the static configurations, because always static configurations have the higher priority. So if you enable any of your interface as access by using the command switch port mode access, ultimately you are disabling DTP over to that interface. Because an access port never listens to the DTP messages. Access is a static port configuration, just like the trunk. But in trunk, negotiations are sent without hearing out. So if there is a combination of two switches having auto and desirable mode, 110% auto will accept the negotiation sent from desirable, and they will agree and convert to a trunk link. There's one more different mode here. What if the trunk link comes in front of an access link? See, both of these are the static modes, right? That means practically none of them will change. Ultimately, such type of connectivity won't end up causing you a creation of access or trunk link. Ultimately, that would be a limited communication. Due to the sense of incompleteness at both the ends of the frames transmission, the switch cannot identify the link's operations. And that's why it will be limited. That means where you have statically configured static, it will remain static only in the administrative mode, and where the person has configured the other part, it will reflect the same thing. So trunk will be visible as trunk, access will be visible as access. Due to this reason, even the frame transmissions will also get affected. Let's say आपके trunk link पर एक port है, एक VLAN associated है, VLAN type, and ये access port आपको VLAN 10 के अलावा बाकी सब पे ट्रैफिक तो भेज नहीं सकता. So let's assume that ये VLAN 10 का ही भेज रहा है. एक्सेस पोर्ट अगर ट्रांसमिशन करेगा तो एक्सेस पोर्ट भाई हमेशा अनटैग्ड फ्रेम भेजता है, बट वो अनटैग्ड फ्रेम इस ट्रंक लिंक से जब एंटर होंगे तो क्या इसको समझ में आएगा? नो, दे विल बी रिप्ड ऑफ, दे वोंट बी आइडेंटिफाइड. So trunk link cannot identify the traffic being transmitted from the access link, and access link cannot identify the traffic being transmitted from the trunk link because it is encapsulated. Access को तो untagged frame से काम करना है, encapsulated का क्या करेगा, right? So this is also one reason, that is the incapability of the frame reading, that also causes the links to be in a limited mode. Okay, enough of the verbal discussion of it. Let's get back to the PPT and see. Yeah, so I just spoke about the auto mode. The switchboard mode or dynamic auto will configure your interface to trunk if neighboring interface is set to trunk or desirable. The desirable mode, it will actively attempt to form a trunk with neighboring interfaces. Switchboard mode trunk, it is basically a variation where you forcefully ask your particular interface to be in trunking mode permanently, regardless of what the neighbor's configurations are. Then comes switchboard mode access. It will force the interface to stay in a permanent non-trunking mode. So this is the entire summary of these particular 4 modes. But guys, do remember, let's say if you have created a trunk link and you don't want someone to violate your DTP configuration topology, what you can do is disable the DTP negotiation transmissions from your trunk configured links. That can be done by implementing the nonegotiate command. Let's see, what I'm going to do here is, see, this is a connectivity. I'll implement trunk interface here, and this particular interface will remain at auto. We just have learned that trunk link क्या करता है, trunk link ना negotiation तो भेजेगा ही भेजेगा सामने कोई भी, तो जिस कारण से ऑटो के पास अगर negotiation गया तो इसको तो trunk link बना देना चाहिए. But I'm going to show you that auto will have the operational state as access and trunk will have its operational state as trunk. Let's see how it is achieved. First of all, let's configure it as trunk. Interface fast Ethernet 0x1. configure terminal, interface fast Ethernet 0x1, switch port mode trunk. I've used the short form. Switch port no negotiate. Now what happened? पहले ट्रंक तो आ गया, बट अब मैंने उसमें से DTP के फ्रेम्स का ट्रांसमिशन रोक दिया. That means ये negotiate नहीं कर पाएगा. As a result of it, let's check the operation state here. Show interface fast Ethernet 0x1 switch port. You see, यहाँ पर डायनेमिक ऑटो ही है और ये अभी स्टैटिक एक्सेस पर. It is not changing its mode irrespective of the time variations. Even if you fast forward timer, let's see, हो सकता है कभी पैकेट से सिमुलेशन में भी इशू लेता है. हम एक बार और देख लेते. Hence proved the power of the no negotiate command. आप no negotiate command का implement करके किसी भी particular interface से DTP transmissions रोक सकते हो. इसको use किया जाता है with conjunction of the trunk link, the switch port mode trunk command, because that is only the static mode of trunk that is recommended to be used in this industrial environment and in the real time. But उसी में problem है कि वो negotiate करता है, तो उसको भी आप इस तरीके से disable कर सकते हो. Whereas if you look on to the trunk ports mode, you show interface fast Ethernet 0x1 switch port. He is sitting here being trunk, and assuming that as I can forward the negotiate messages, definitely the link will end up on causing the trunking only. But he doesn't know the no negotiates power that we have used. So guys, ये तो है DTP के modes के variations का combination. I have not discussed those layman usual modes. Auto combination में definitely trunk नहीं बनेगा because they both cannot send, right? Now, moving ahead, a quick review. Dynamic auto mode, it will only become trunk if neighbor is in trunking or the desirable mode. Dynamic desirable mode, it will actively form a trunk with the neighbor happily. If you have manually created the trunk link, the trunk mode, switch port mode trunk command, it will force permanent trunking on the interface. Access mode, it will force non-trunking on the interface. And no negotiate, it will very silently stop the DTP by disabling frame transmissions. So I hope you guys have been properly thorough with this particular explanation. We have seen negotiation modes, encapsulation selection, trunk establishment also we have seen. All these modes are also done. Okay, yeah, there is something left. Let me just catch that scenario too. We've done with the commands. We reached on to the brief. Okay, it will end up at the brief and then we'll have to jump to that particular part. Nice. Okay, now let's move ahead. Now we'll look on for the configurations part. There are some troubleshooting commands that you guys can use. One is show DTP. Show DTP command always displays the DTP information of all the interfaces. How can you use it? Not a question that needs to be asked, but still, show DTP. It will tell you कि आपका DTP information कितने frequency पे share किया जाएगा, trunk कितने वक्त बाद breakdown होगा. Let's say यहाँ पर मेरे पास trunk timeout timer होता है 300 सेकंड का, जबकि DTP का hello timer होता है 30 seconds. Okay. So what will happen in this 30 and 300 combination is switch 0 sent the DTP negotiation. So I'll send this negotiation in a frequency of 30 seconds every time. But my negotiation messages will advise the neighboring switcher to hold these particular trunk combination of the link status for the next 300 seconds if they agree. So I'm showing a scenario of the agreement scenario, right? That where this particular DTP negotiation message was agreed upon. As soon as switch 1 agreed upon the negotiation, a timer of 300 seconds has started for the link. Now what happened? Once the second scenario started, I use the no negotiate command here. If I use the no negotiate command, it won't be sending out the negotiation. And once this timer that is still reducing will come up to 0, the switch 1 will flush out the trunk link configurations and your link will again behave as the normal. Would you like to see it? Let's check. Let's check the real behavior. How will it behave? How can we do it? Let's first of all create a trunk link with the DTP negotiations. Okay, so what I'll do is interface configure terminal interface fast ethernet 0x1 switch port no negotiate for the command. Let's do a negate of it. Okay, now switch port mode trunk. Let's see if no negotiate has been removed, because I don't remember the no negotiate, basically that particular syntax of negate. So this message has to be up. One still not happening. Let me just take another switch. Test it on. Creating desirable must have sent the negotiation messages, and other end is auto, so definitely trunk link must have been formed. But I'm not sure whether it will be updated in the entries also or not. We'll see. I'm doing this for the first time even. Show face fast entries by one switch port 2. Dynamic desirable and trunk. Now let's see what happens if the negotiate command has been applied. Switch port no negotiate. First of all, no negotiate cannot work with the dynamic status. Correct. That was basically only for the trunk link explanation that was given in the lab itself. While I was doing the trunk implementation, that has been done. I literally was confused whether how come it can be done with the dynamic mode, because in dynamic no negotiate never works. Yeah, that was a similar explanation here. Now Guys, DTP has only this much in its box. What else I'd like to discuss here could be some of the case studies for DTP configurations. Okay, so while talking about DTP, what all things do we know? We are aware that this particular DTP is something which basically creates the trunk links automatically. Okay, so first I have sorted here 4 different cases. Just give me a second, I'll just have some water and then we'll start. Okay, now we are going to explore the importance of understanding and configuring the DTP, that too in Cisco's network. So here I have 4 real world case studies that might highlight common challenges and solutions which are related to DTP. Let's reach on to the case study number 1. The unintentional trunk formation. To assume that there is a very new server implemented or connected to a switch. We have already a switch supporting the entire switched network of mine, and a server has been connected. This is a scenario, and there is an unintended trunk link that has been formed due to default DTP settings. The server, once connected with my particular switch, has formed the trunk link, and that was not done intentionally. Okay, that was due to DTP's default behavior. So what could be the problem here in this scenario? If one such unintentional connectivity can give rise to the trunk link creation due to DTP's automatic supplies, your VLAN traffic will be exposed to the server. And assume multiple VLANs traffic being exposed to a server, it can pose a major security risk. So the only solution here in such a scenario could be, once you disable DTP on switch port, okay, and this particular switch port should only be configured statically as access, the access port. In such scenario, access won't entertain the DTPs ever, and this type of unintentional trunk creation will never be a scenario. This is also a recommended method that Cisco also recommends to its users. Let's jump on to the second case study here. Incompatible devices, a cool one. So assume you have a non-Cisco IP phone. Okay, this IP phone, it is a non-Cisco one. Now this non-Cisco IP phone is experiencing connectivity issues because of incompatible DTP settings, because this non-Cisco device is connected to a Cisco switch. What could be the cause of outcome of this particular issue? If one such connectivity has been achieved between the non-vendor and the Cisco specific device, the intermittent connectivity and the VLAN mismatches will cause trouble here. The solution in such scenarios would be to disable the DTP on that particular switch port and manually configure the particular port as trunk, as well as the appropriate VLAN. Don't configure it automatically. Go and prefer the manual configurations. So guys, out of these 2 particular case studies, the only key takeaway is that disabling DTP Okay, and the manual configuration of the links, manual switch port configurations, I must say. These are the things that you should always deal whenever you are dealing with the incompatible devices, or let's say a huge network. Even if it is a huge network, never go for DTP, I'll recommend. That will possess huge security risk for you, because I can take any particular information out of your switched environment having multiple VLAN support within the connectivity of a single link itself. The next study, troubleshooting trunk issue. Assume the scenario where your trunk link between two switches was flapping, and the reason was the network disruption. So what will happen is your DTP negotiations, right? Your suspected DTP negotiation issue will rise. And the only solution here would be, what can be done? Yeah, what you can do is you can temporarily disable DTP here on both the ends of the trunk, so that it can isolate the problem. Once you have investigated later on and rectified the DTP settings, then re-enable the DTP. That would be the smart way of working in case of the flapping issues. Now the final one more we can discuss about the access ports. See, what happens is, let's say you're working in an environment and a security audit came to your office, okay, and the audit report told me that it revealed unused switch ports in the dynamic auto mode, and the report says that these particular unused dynamic auto mode set switch ports, they possess the potential vulnerabilities to my switch network. Sounds right? It even sounds terrifying. Exactly. Guys, what happens is, if I'm an attacker, as I was saying, I too will recommend never think of it, right? Because if I'm an attacker, so I can easily plug in any rogue device to that particular port and negotiate for the trunk, right? Thus, I can easily gain the access of the VLAN traffic. And do remember, guys, one more thing, that if you guys have studied these things, even an attacker must. And they always plan the attacks to be steps ahead of your thinking. So be very cautious while configuring and deploying these particular devices. Although the configurations are pretty easy, right? But even these particular easy and single or dual step configurations might cause a huge trouble in your network if not given immense care. So for the conclusion, as we've seen, the understanding and proper configuring of the DTP, that is crucial if you want your network to be secure, stable, as well as compatible. So if this three words, a secure, compatible, as well as a stable network, is your dream, remember to explicitly configure switch ports, disable DTP. I'll write it for you. Explicitly configure switch ports, disable DTP when not needed, use DTP troubleshooting techniques. And yes, a regular audit of your network is a mandate for identifying the potential vulnerabilities. So thank you so much, guys, for this attention. If anyone has any question, feel free to drop it in the comment box. Day by day, we'll be advancing, excelling over to the topic. Sometimes, yeah, if I move way too into the topic. That's why I take a break and come back. Any questions from anyone in the viewers, or if you are watching this video later on and you find that you have any particular query that you want to ask, please drop in the comment box. Okay guys, so I'll be calling it the close for the day. So here we have ended up the day at Dynamic Trunking Protocol. I hope you might have found this particular session deep dived all the DTP informative and helpful. Although understanding DTP is crucial for anyone pursuing CCNA certification or looking to enhance their networking skills. Even I'm glad we could explore it together today. Thank you so much for joining me and for your active participation. There might be some questions as well as these particular engagements that you guys make. This is the only reason why these sessions become somehow very valuable. If there are any other question or clarification needed on anything that we have covered, feel free to leave the comments below. Guys, the usual thing, if you have enjoyed this session, please do give a thumbs up and subscribe to the channel if you haven't already. And these small support, positive support that you guys give, that continuously helps us to bring and offer you the high quality content and ensure that you should not miss any particular future sessions. Before we wrap up, I have an exciting announcement about our next session. Next week, we'll be diving into another essential topic in CCNA curriculum. Although you might not find it within your Cisco syllabus, the 200301 PDF format or the website even, it does not hold VTP as a topic there, right? But VLAN trunking protocol or VTP is a critical protocol when it comes to the management of the VLAN across a network. So understanding it will further enhance your network management skills. So do make sure to mark your calendars and join us next week for what promises to be another insightful session. Until then, keep practicing and exploring the world of networking. Stay curious and stay motivated. Do keep pushing the boundaries of your knowledge. And thank you once again for being here. Have a great evening. I'll see you next week for our session on VTP. Take care. Happy networking.
spinning. Try to work it out, it's spinning. Ever since my heart's been missing. Spent the last 2 weeks just grinning. I spent the last 2 Thank you.